Hi all, good morning. So in today's session we will discuss about the SQL optimization or SQL tuning. Earlier we discussed about the basic about how can we tune the database, which are the part of that. But in that hardware optimization, database optimization, query tuning also part there. So apart from that, the data tuning also there part. So these are the multiple things are there. You can check out the previous session, but in this session we'll check about the data tuning and SQL query optimization. So there are multiple ways to optimize the query. First is you know that the basic about the database, like this is the database, but database is a part in database there are multiple tables are there, and in this table and table associate with the data. Okay, and this is your database. Okay, that's why we are calling database, like data and data. So data is more important to and how we are storing that data, which form we are storing that data, that's also important. So query tuning is a two part. First is the data, all about the data and how we are accessing that data. This is the indirect query optimization, and next is the direct optimization. This means the queries, how we are accessing the data. Is it where clause is correct, how many inner queries we put, all the things are in query tuning. Means the direct query optimization. And indexing, is there index get applied, full table scan, how the partially query we are preparing, means pairing query on partial indexing, how things are going, that will check in direct query optimization. Okay, first we discuss about the data part. So yeah, data or a database should store the data for machine and display for the human. This should be the behavior of our application, because whatever you are currently seeing, that is a representation form, but its background is stored into 0 0 0 0 1 1 1 0 0. Everything is 0 and 1 for the system. That's why I'm saying that store for machine and display for the human. Currently this video is we see on the screen, but backend it's a binary code. So if you are writing any system, think in a such a way, you don't want to display that whatever stored into table. It's structural representative or a saving. So store that. Suppose if you build any application and some cart application or some order application where you get to know the order status, like it's in place or in progress, completed and close, that kind of status are there, or deleted. But these statuses, it's UI representation where you need to show that delete, this is a progress, this is a complete, or this is not started kind of thing. But it won't require to store at a database level. You can easily store that as a 0 1 2 3, and when you are showing that on a UI, you simply convert 0 to not started, 1 for complete, 2 for progress, and 3 for delete. That's my point where I'm trying to say. Okay, less data is more performance. Like if you go and check storing status into string and storing a status into integer, which will provide the better result, and you get to know that integer always a good performance. So that's why I'm saying that try to go with the integer or the machine understanding language. Apart from that, data storing, like if you go and check that how many domains are, or how many apps are stored into Play Store, you get to know numbers in billions. But if you check that most active applications that are in a case, means 100k or 10k, that it's in 1,000, but total is in millions. Why this is the case? Because everywhere if you go on any domain, you get to know that domains are in millions, but how many domains we remember? YouTube, Facebook, Insta, LinkedIn, that's it, and Google most of. So that we know, I think maximum 100 domain we know, but it's ideally it's in millions. So that's why whatever data is required, that only we should store, because we are not a Google. We are writing applications for few folks. So why we are storing unnecessary data if it's required, or store this million kind of rows in archival thing, not in active. You prepare a two database or a two tables where one is for active copy only and one is for logging purpose. So whatever data in your system have that you put into logger or archival tables, and whatever active last 90 days active data you put into main table and perform that operation. That always provide a better result as per my experience. Next point is store data into small, simple and appropriate format. Like if the just an example, we took that status kind of thing. Go with the integer, no need of a string and fancy things. Yeah. Try to avoid a null data, because if you are putting null, means that some value is there. So instead, don't put such columns where null value we are putting. Use such default values or some sensible things in that. Use the integer identifier. We already evaluated that in a status thing. Always try to think return only needed column. This is the most common problem I saw across the industry, where we don't know how much columns and what columns we require. So why we are pairing query? Whatever column is required, that only places under the select. If you do star and suppose the 10 column added into that table, then your select getting hampered, because a lot of data you are pulling from database and that resides in your application memory. So leave it. Don't need that kind of a select star statement. Use only selected columns. It useful for SQL query execution, always a SQL query execution. Apart from that, it's also useful when you are pulling into in-memory data, and operation on that memory also get faster. So if you correct one thing, 10 thing gets easy for you. And if you do select star, and the issue you won't get identify easily, because this kind of mistake we do, and we try to find out for optimization or other optimization basic things. If you collect, that also gives a better result. Reduce query complexity. Like if you use the explain plan, go and whatever query you have, like I want to select employee, so I go say select star from employee, okay, employee table, and where employee name is equal to Ram, or I say like is equal to Ram. So if this query took time, you just go and write a explain here. So if you write explain, these MySQL provide explain plan, means how internally get executed, which are the applicable index for this, which index the database will pick for execution, this, that kind of information provided by explain plan. So it's always advisable to, whenever you are writing a query, first check explain plan and use the existing index. Not every time you can go and create the new index, and that creates a lot of burden, because when you are inserting and updating a data, that the index is the weapon where you should use wisely, because if you add the index, select get faster, but insert and update gets slower. So you need to use wisely. Apart from limiting a row, suppose you have, we already said that you have 10k row and only on a web page 10 record is getting displayed and 1000 pages are there. So at the first place, why you are pulling this 1000 pages now? Only show this 10 row on a UI, and whenever user asks, then go and fetch next 10 rows. So paging should be there. Apart from that, check on the sorting thing. Is it really required at a database? What is the time when we apply sorting at a database? What is the time when we are applying at application level? Both the things need to be taken care. And overcome to the fragmentation, means like we have the 10k rows, and in a day there 5000 get rows added and 5000 get deleted. So in this case, lot of fragmentation is created, because every day new data get inserted, old data get deleted. So a lot of operations are there, and only 50% data get written on the next day. So on such tables, ideally quarterly or monthly, we should optimize that table, so that will get a better result for our thing. Yeah, that's the part one. In the second part, we'll discuss some basics about the yeah, we already discussed every column should be getting used. Don't use the select star. That's the most common mistake we are doing. Every column and value should be compacted and practical. Suppose if you have the table like title and genre, you should ideally create two tables. One is a title and one is a genre. So title have the title genre ID, and genre ID, this is a mapping is there, means title have the genre ID and genre ID is there. This is a normalization form. So if you want a specific genre name, you can just use this genre ID and genre ID and map it here. No need to duplicate that data. In genre, 3 are the computers, so these are the redundant data. You can easily swap, just creating a one as a column for computer and preparing a three rows. So that way, this and this. So this is the basic example where how data should be stored. Every secondary index use not duplicate index. We already covered in index part. Only needed row kept. We already covered this. One example, how the data get reduced, like varchar 255. Instead of if you put enum and store in a character 2, that also useful. Already we discussed in the status. This is the same example, means if you want to store ABC, just put it means A for apple, B for ball, and C for cat, and this is a duplicate data. So just create an enum out of that and store only ABC as a character of that. Yeah, int, if you you can use unsigned also if you choose go with the int, but if you use int unsigned, then you will get a 4 million. If I am preparing ID as a int, and ID never go into negative number, it's always unique and auto incrementable. So you choose int unsigned, you have the 4 million as a thing, as a 2 million additional data or a counter you will get to here. So yeah, wisely we can choose that, not just moving to the long or a big int. First whatever we have, we should evaluate all the steps. Duplicate applying normalization for me, yes, deduplication happen, we covered that 1 2. This is a computer, and three times we are mentioning computer. It's not like as a JVM. In a JVM, string constant pool, if you create a one string, that only mapped. This is a MySQL, so every time memory gets allocated for everyone. So think wisely. Apart from that, data cleaning, we already discussed, only 90 days active data we should put into database. So yeah, PTR card delete tool we can use, so the database lock won't happen and data get smoother to delete operation. Yeah. These all about the data, and we covered indirect query optimization here. Access pattern, how data we are accessing, we already discuss about select star and all the steps. We'll quickly move upon direct query optimization, where we say queries and indexing. Queries and indexing, I think indexing we cover in a different session, and queries we just check about. Okay, do not need to scale a hardware to performance improvement until all options are executed, because we know that how index getting applied, how query get formed, what is the where clause, what are the group by where things, subqueries are there, what are joins we are applying, is it required that much joins, all the stuffs are need to evaluate first, and then need to think on the hardware, because MySQL, we in a one section we discuss about that. MySQL is a provided horizontal scaling. You can check it out how the horizontal scaling will happen. But yeah, that's a simple thing. So first of all, check all the options and then go on a horizontal scaling. InnoDB is a special cluster index is provided to best performance. Means there are multiple MySys and other engines provided by MySQL, but if you choose the InnoDB table, that provide one cluster index on your table by default. So when you are firing any query on your database, first that cluster index get applied. If that cluster index is providing a better result, then we MySQL use that cluster index. Otherwise they fall back onto next index and check which will provide the better result. Yeah, if table has a primary key, InnoDB use that as a cluster index. Yes, we discussed. Query uses leftmost to prefix for index. From left to right, query get executed. Like where if you say employee name is equal to Ram, employee is equal to 1. So left to right, query execution happen. Index is based upon where, group by, and order by. So suppose I say that where name is equal to Ram, group by on ID, and order by on address. And if you have index on name, ID, and address, so what do you think? Is it get applied? Yes, because name is in where, ID is in here, address is here, and it's already there. Index is index data, so we can easily get this data by the index. Apart from that, index lookup, index scan, and full table scan, these are the 3 access pattern of index. So in this index, suppose we are selecting name and ID. If you are selecting name and ID from employee, and where clause is this is the same. Okay, so that means name is already present here and ID also present into group by. So whatever data we are selected, it's already present into where index. So this is the index lookup. But if you say name, ID, and I want blood group, these are the 3 things. So name and ID is there, but blood group is not there. So partially we are doing index scan, but blood group we require pull from the table. So this is the index scan. And if we are selecting only blood group, not rest of the things, that time this is a full my bad. So index scan is this, and the full table scan, if you put where blood group is equal to B positive, we need to find out B positive peoples. So blood group is not in index column, or it's not, new index is added here. So that time all the table need to go through that table. That's a full table scan. Yeah. And another example, so if you have 10 rows, I think I already took this example. If in database you have 10 rows and employees table and gender, and you had 2 possible values, male and female for gender. 5 rows are for male, 5 are female. And if the gender is indexed, then, and you are finding out the male count, then only 5 rows need to travel. But if gender is not indexed, then whole the 10 row need to go through all the 10 rows. So that's why full table scan. Full table scan means all the 10 row need to travel. Index scan and index lookup, only you know where need to go and which data rows need to be evaluated. That present into index lookup and index scan. Yeah, that's it for today's session. Thanks all. Bye. See you next time.